Welcome to Unit 3, Section 3, Solving Multi-Step Equations. So in the last lesson, we used inverse operations to solve equations like this, right? When we saw a multiplication, we used division, and vice versa. And we used reciprocal when we saw something like this. So take a moment and complete these 4 questions. Pause the video now, and when we resume, we'll look at the solutions. Okay, so hopefully you had a crack at those. Here are the solutions. So in the first example, we just used division, divided by minus 13, and doing that to both sides gets us x equals 9. For number 2, it was just a matter of multiplying both sides by minus 4. Remember, there's a 4 down here, but there's also a minus sign, a negative there. And so we have to multiply by negative 4 in order to get rid of both the 4 and the negative. Okay, and for number 3, I multiply both sides by 4/3 because we had 3/4 there, right? So the reciprocal of 3/4. And that got us 8 over 15. And likewise, over here, I multiplied by the reciprocal of 7 over minus 3, which got us negative 3 over 7 times 4, or negative 12 over 7. Okay, so we're going to start today's lesson with a little investigation. So let's consider solving the following equations, whose answers are both x equals 3. So really, each of these have what we call 2 steps because we see, in this case, we see multiplication and addition. We see 2 terms. In order to get x alone here, there are 2 things to do. First, we have to take care of either the multiplication or this addition, okay, first, using opposite operations. So in what order should they be applied? Well, let's have a look at what happens when we do it in either case. So, let's start by starting with handling our addition first. We know that this plus 4 here is causing this x not to be isolated, right? And so to get rid of this plus 4, we can literally subtract it from both sides, and we get 2x is equal to 10 minus 4, right? Or 2x is equal to 6. And then we can solve for x by dividing both sides by 2. So we get x equals 3. So that wasn't too bad. But what if we had actually just done our division first? What if we divided by 2? Okay, well, remember that when we do this, we have to divide everything on the left side by 2, right? The whole left side, if we're going to divide by 2. So in other words, we would have to go like this. We'd have 2x plus 4 equals 10. And we could divide each of these by 2. And we would get the following. Well, we know that the 2's here, they cancel. We would get x. And 4 divided by 2 is 2. And 10 divided by 2 is 5. Okay, so this wasn't too bad, actually. Really, we just have to move now this 2 over. Subtract it from both sides, and we get 5 minus 2, which is equal to x, which is equal to 3. So x equals 3. So either of these methods actually worked fine. However, it's not always the case, okay? Sometimes, quite often, it's easier actually just to start by moving a constant, if you have it like this, sitting here, over to the right side, which is this addition, if you think, is actually lower in order of operations than multiplication, right? And so this is a curious thing, how when it comes time to solve for a variable, the most efficient method is often, or reliable method, is often lower on the BEDMAS, right? The order of operations rank chart. So let's see what happens over here. X divided by 3 minus 1 equals 0. So in this case, in order to solve for x, we need to move this, somehow get rid of this minus 1 by adding 1, and we have to multiply by 3 to get rid of this division. So let's start by handling the minus 1 first. So what if we do that? Well, basically we're adding 1 to both sides. That brings the 1 to the right. I get plus 1, and then we can divide or multiply both sides by 3, right? And we get 1 times 3, which is just 3. So x equals 3. So very simple. Now, what if we were to do our multiplication first? All right, so multiplying first would mean would mean multiplying literally everything on each side by 3. Because we can't just multiply this part. This is the key here. If we're going to multiply the left side by 3, what we're really doing is this. 3 times everything that's there. X over 3 minus 1 is equal to 3 times 0, which is on our right side, which we know is just going to be 0. But now look what we have to do. Notice how we have a distribution here now? Because inside, we have a binomial, and we have to multiply it by 3. In other words, this 3 is going to have to interact with this first term, and also the minus 1. So we're going to end up getting 3 times x over 3. Well, that's fine. That's going to cancel. But then we're going to have 3 times minus 1, which is minus 3. And that's going to be equal to 0. So, to finish solving this, we could move the minus 3 to the right side, and we get x equals 3. So we did get to the same answer here, but if you'll notice, right, this was quite a bit more work. So, in general, it's better to use addition and subtraction first, if you can move terms over that do not have a variable, right? In other words, a constant, and then handle any multiplication or division that's affecting the side with a variable. And if you stick to this order, you will be in good shape. Okay, so let's do some examples. Let's look at this one now. If we have 5x plus 13 equals negative 11. So like I said, what we're going to do first is get rid of this 13. We're going to subtract it from both sides. That gets us negative 11 minus 13. So we end up with 5x equals negative 24, and therefore dividing both sides by 5, pardon me, there we go, we end up with x equals, well, negative 24 over 5. That can't be reduced, right? It's not divisible by 5. And just imagine what would have happened here is if we had tried to divide everything by 5 first. Right? Well, we would have ended up, and you don't have to write this, but I'll just show you what would have happened. If we divide by 5 first, we would have had 5x over 5, but we also have to divide 13 by 5 and negative 11 by 5, right? And so then we'd end up with x plus 13 over 5 equals negative 11 over 5, and this isn't horrible. It's nothing that we couldn't do. However, we do end up with fractions, right? And we have to move fractions around. So it's a little better, like I said, to move that 13 first. How about for number 2? So number 2, well, what if we, in this case, move this minus 13 first? Let's try it. Well, we'd end up with x over 13, right? That's the one here. And we move that minus 13 over to the right. We end up with a negative 12 plus 13. And bring this up here. We can now multiply both sides by 13. Actually, we're not quite ready to do that. Let's take another step. X over 13 equals this negative 12 plus 13 is 1. And now we can multiply both sides by 13. That gives us x equals 13. Okay. So that's not so bad. We'll just leave it there. And I want to go through some more examples and give you some time to work. So let's rock our way through these. Number 1. Again, so 3x plus 9 equals negative 18. Let's move that 9 to the right, and we end up with negative 18 minus 9. So 3x equals minus 27. And dividing by 3, x equals minus 9. Okay. And we're just going to kind of work straight down the line here, I guess. 1, 2, 3, 4. 2.7x, or 2.9x minus 3.7 equals 11.3. Really, this is just the same process, except we have decimals, right? So we can still keep this 2.9x and move the 3.7 over to the right. Make sure to change the sign. So we end up with 2.9x equals 15, right? Okay. And so then we can divide both sides by 2.9, and we end up with x equals, let me just get my calculator out here, so 15 divided by 2.9, about 5.17, right? 5.17. You can use decimal there because decimals were in the question. All right, number 3. This time we have a y over on the right side. So let's clean this up as much as we can. We have a term here, a constant term, minus 10, so let's take care of that first. We'll move it to the right, and that'll give us a plus 10, right? Plus 98 equals minus 12y. And so 108 equals minus 12y. And dividing both sides by minus 12 yields y equals minus 9. Number 4. So this time we have x's on both sides and constants on both sides, right? So let's move our x's to the left, minus 5x plus 2x, and our constants to the right. So this minus 3. Let's pull that over to the right side. So we have minus 4 plus 3. So that's good. Now we can collect like terms. That's the goal, right? For these, you want to move things to the right place so that you can collect like terms. So now we'll have minus 3x equals negative 1. And we can divide both sides by minus 3. And we end up with x equals positive 1 over 3. We have two negatives here, right? So those cancel. Okay, up we go to number 5. So number 5, this time we have 0 equals 3 plus x over 3. But really, this is the same thing. We just need to move this 3 over to the right side, or in this case, to the left side. So we'll have minus 3 is equal to x over 3. And therefore, multiplying by 3, we get x equals minus 9. Notice how I didn't show as many steps here. This is okay if you understand once you get the pattern. For now, as you're starting out, when you first start doing these questions, show a little more work until you get into the habit of doing these properly. And certainly don't do these in one step, right? I'm going to be looking for at least one step on questions like this when you do your homework. Okay, number 6, x over 3. This time we'll move the minus 1 over, so we're going to have 2 plus 1. So we get x over 3 equals 3. And multiplying by 3, x equals 9. Hopefully you're getting the pattern here, right? This is getting repetitive. A lot of these are pretty similar. So we'll just kind of fly through the rest of them. 10 minus x over 2. So this time we gotta take care of that 10, right? But it's gonna leave a minus x over 2 on the left. 4.5 minus 10. So multiplying both sides by negative 2, and well, first of all, collecting like terms over here, we should do that. So we're going to have minus x over 2 equals negative 5.5. And multiplying both sides by minus 2 gives us the following, gives us x equals minus 2 times negative 5.5. And so therefore x is equal to 11. Okay, last one. So for number 8 here, of course, x over 5. We got to move that 2 over, and we're going to get that, right? Minus 2. And so x over 5 equals minus 5. And so the only option, therefore, multiplying both sides by 5 gives us negative 25. And that's our answer. Okay, so complete practice questions 1 to 14 on the handout, and we'll see you in the next lesson. Good luck, guys.